Number 18, determine the oxidation states of the elements in the compounds listed, and none of the oxygen-containing compounds are peroxides or superoxides. So thank you for that little tip. And now we have to find out the oxidation states of Cl, N, and O in chlorine nitrite, if we had to name this. So the first thing I'm going to do is I'm going to just write this big on this side, ClNO2. Okay. Now, there's tons of ways to do this, right? What I'm going to do is I'm going to try to separate as much as I can, try to break this compound down to find each individual oxidation state. Now, the first thing, before we even dive into this, just make sure that you guys memorize this oxidation state trend, okay? Normally, elements that are in group 1 want to lose 1 electron. The plus means lose. Elements in group 2 normally want to lose 2 electrons. 13 or 3A, they want to lose 3 electrons, and then the trend keeps going on. The negatives just means that you're flipping over, so you're gaining electrons. So this group generally wants to gain 3 electrons, this group generally wants to gain 2 electrons, etc., etc. If you want to know why this trend exists the way that it does, you could check out number 16A in the playlist. The link for the playlist is, I think, at the end screen of this video. So go check that out if you guys aren't on the playlist already. Okay, so let's see. I'm looking at this and I noticed something, right? Because we've done tons and tons of problems before, that I notice this NO2. And I hope you guys notice that as well, right? NO2 is a what? NO2, and maybe I'll put it over here. NO2 is a polyatomic. Remember, you guys can't get away from those polyatomics. It's just easy to know what they are. Memorize them, okay? Because I memorized them, and I could automatically spot out that this was a polyatomic. NO2 is nitrite. Okay? Now, do you guys know what the charge of NO2 collectively is? Yeah, nitrite is always a -1. So, what I'm going to do is I'm going to break this nitrite away from the chlorine. Remember, when we made these compounds, we had charges in the upper right-hand side, right, in which we crisscrossed down to get our numbers. This case, we're going to be doing the exact opposite. We have the compound, so we can just take those subscripts and crisscross them back up. Now, it's chlorine, right? There's 1 chlorine, and this is why you have to know your polyatomics, because since the 2 is included in the whole polyatomic, I know that I have only 1 nitrite. I don't have 2 NOs, right? This 2 only goes to the oxygen anyway. So I have 1 whole nitrite, and those are your 2 subscripts that you're going to crisscross up. Let's start with this one first, right? This one crisscrossed up to tell me that the nitrite was a -1. And remember, the negatives go in the back. And it checks out, right? My knowledge of nitrite is that it is a -1 charge, so that makes sense. And then this one crisscrossed up to tell me that the chlorine was a +1 charge. So let's write down what we have so far. We have a Cl being a +1 and a NO2 collectively being a -1. Now, since my knowledge of nitrite is that it is a -1, this checks out, which means that this has to check out. So chlorine is a great example of that. Even though on the trend it says that it wants to be a -1 charge, sometimes they can be different. So just watch out for that. But they give you little telltale signs, right? Chlorine was in the front, and usually, the front guys are positives. So that's already indicating that, chlorine's not going to abide by the rules. It's a rule breaker. So Cl, in this example, is a +1 charge. And plus, remember, means that you lost electrons. In this case, the chlorine lost 1 electron. That's an ugly That's an ugly one. There you go. Okay. So now we have to just signal out N and O, nitrogen and oxygen, from the nitrite. Now they gave us a little tip here. They said none of the oxygen-containing compounds are peroxides or superoxides. So that means that oxygen has to abide by the rules. Oxygen has a -2 charge. Only when the oxygens are in peroxides or superoxides does it not have that -2. All other times, it will abide by the rules of the trend, right? So I know that this oxygen has to be a -2 charge. But now the thing is that I don't really know what the nitrogen is, right? Now, keep in mind that the nitrogen is in the front, which means that it should be a positive. On our trend here, the nitrogen is a -3. Do you think that that one's going to abide by the rules, or is it a rule breaker? Yeah, in this case, nitrogen is also a rule breaker. So we got to figure out what this nitrogen is. Now, remember, and if I can do this a little bit better, and maybe I can just make this a little bigger because we're going to have to do some math. So we have NO2, right? And this all equaled the -1. The -1 is the total charge. So that's super important. This nitrogen plus the oxygen will have to equal the total charge. In this case, it's the -1. But now there's two things that you have to take notice when you are going to solve for your unknown. And the unknown, remember, is the nitrogen. You need to tell me how many you have and the oxidation state of that element. Now, from NO2, there's only one N, right? There's a secret 1 down here. So I know that I have 1 nitrogen, but I don't know the oxidation state. So I'm just going to call that X. Now, what about for oxygen? Well, we said that there was 2, right? Over here, there's 2 oxygen, so I have 2. And we said before that oxygen will have that -2. It's not a rule breaker. Now, the addition of these, right, the nitrogen plus the oxygen equals the -1. What you're going to do is you're just going to multiply these two things together. So you multiply everything you know about nitrogen and everything that you know about oxygen to make a nice little chart, or a nice little algebraic expression. So 1 times X would just be X. 2 times -2 is a -4. So X plus a -4 is the same thing as X minus 4. And now we have a nice little formula. X minus 4 equals a -1. It equals the total charge. So let's just do algebra. Plus 4 on both sides, plus 4. This cancels out. And X actually equals a +3. And that is the oxidation state of the nitrogen. That's what the X was. So we solved the puzzle. We know that oxygen was a -2. So that means that all of them gained 2 electrons. And the nitrogen, which we found out, was a +3. It lost 3 electrons. And that is your final answer. So that's how you separate out your elements. Identify the polyatomic and then just keep breaking it down from there. What do you guys think? Let me know in the comments if this helped you out. Give this video a thumbs up or a like if it did, and hit the subscribe button, which will help us out, and we greatly appreciate you guys. I hope we are helping you out. But anyway, I hope you guys have a great day and keep studying hard. You guys got this. All right, let's ace those quizzes and tests, and I'll see you guys all in the next lesson. Bye-bye.